Okay, we left this, so I was going to be adjusting my Enfield Bullet distributor to remove play in the shaft. There's a considerable amount of end float on this, which is definitely going to be affecting the way the system works. There's very little, if any, side play in it, so the bushings are good, but what I need to do is put some shims in here to remove some of this movement. Hitchcock's motorcycles do supply shims for this job. I'll just show you one. They are 16 by 19 millimeters and 0.3 wide, and they fit over the shaft, but where the fit is between the pinion and the step at the end of the taper. What I found is if you put more than a couple on, you stop the pinion seating properly on the taper. It's certainly not enough to remove the amount of play that's in this one. So I ordered some other shims. I got some shims which are 18 by 25. So you see that compared to the Hitchcock's one. The 18 is enough to butt against the inside of the pinion, and the 25 is absolutely perfect for sitting into the recess here. So what I found is if I used a 1.5, so I should put these in the other way. If I used a 0.1, two 0.3s and a 1.5, then refit the pinion, which is engaging with the taper, that significantly reduces the amount of play in this, I think, to an acceptable level. So what we now have is quite a small amount of play. There is another factor here, in that this housing is aluminium and the shaft is made of steel, and this does get hot, and aluminium expands quite a lot more than steel when it gets hot. So what we don't want is to completely remove all the play. We need a little bit of end float to stop this binding up when this expands and gets hot. For the temperatures we're talking about, you can more or less count the expansion in the steel shaft as zero. It's very, very small distances. I looked up the coefficient of expansion of aluminium, magnesium would probably be more, which is 0.024 millimeters per meter per degree Celsius. What that equates to is a metre of aluminium would expand by 0.024 millimeters for every degree you warm it up. So these get hot. They get too hot to touch sometimes if you've done a long journey. They probably don't hit 100 degrees. I don't think liquid would vaporise as soon as it hit it. So I would, at a reasonable estimate, say they probably get up to 80 degrees. You wouldn't be able to hold on to it, but you'd be able to touch it without burning yourself. So assuming that our maximum temperature change is 80 degrees, we've got a 75 millimeter ish piece of aluminium. We're looking at 0.14, 0.15 millimeters of expansion when it heats up. So I need to make sure that that distance, if I was to measure it in here, between the maximum and minimum play is more than 0.15, or bang on 0.15 would be absolutely fine, which it is. So I've got it to, it's about 0.17, I think, here, and I think that's going to be absolutely fine. We're concerned about lubrication in here. This whole area is splash lubricated from the oil in the timing chest. If you choose to pump a bit of grease in there, it would send some that way as well. So I'm not too worried about the friction between the pinion and the shims. The other thing is that there's no thrust load on this, so it doesn't actually have anything pushing it backwards and forwards this way. It's entirely rotation. It's just spun by the idler gear. There's no real load side to side. So that's pretty much ready to put back on the bike. I also made a new gasket out of cereal packet. I find Alpine and Kellogg's ones seem to work best. They seem to have a sort of waxed cardboard. We're not too fussy about tolerances with where this bolts onto the side, so that's generally absolutely fine. So we'll have a look at the bike. Okay, so here we are at the bike. I'm going to put the casting back on now. So the only thing you really need to be cognizant of is the grease nipple needs to be facing up so you can get at it. I've got my gasket installed. I have applied some gasket compound to this because I was getting some blow past before. I've probably solved that by introducing a breather into the timing side, but I use Permabond A136 for most of these kind of things. Very forgiving gasket material. It doesn't set, spreads on easily, smells like sweeties, so yeah, that's a winner. I'm going to come round to the other side of the bike to fit it so I can get it lined up better. That's somewhere close. And we've got these set screws to hold it on with. Unusually for Enfield, they have used a reasonably coarse thread in going into alloy. Not so keen on slotted heads, but they work, and they've got quite aggressive spring washers. So hopefully if we can get a couple of these started, we'll be in business. That's one going. Okay, I'll turn you back on when I have these tightened down. Just worth noting, you actually need to remove this idler gear as well in order to get this bolt in. So next steps to install the distributor shaft. I've applied a thin skim of grease on here. It may take a while for oil to work its way up to that point. They do have a grease nipple fitted to them, so there's also intended to be some grease there. I have degreased the taper. I was always taught that you should degrease a taper so it gets a proper grip. So I'll pop round to the other side and fit that. Okay. So the next thing we're going to need are my shims, and I'm going to put the thinner ones on the inside so there's no risk of them popping out of that recess. And then we're going to put the pinion on, and they've popped out the recess. We might need the help of a little bit of grease here, we'll see. They just need to stay put for 2 seconds. No. Okay. So they're not going to play the game. I'll just put a little tiny smear of grease on just to sort of glue those in place. There we go. And pinion. Okay, so next thing is the nut. end there. Now, something I found was that there doesn't seem to be a tightening torque listed for this. I want it unreasonably tight because it's engaging with a taper. That said, there's very little load on it. The other thing that you may have noticed is, as I'm going to turn this, it's going to try and rotate the engine. A trick I was taught years ago was an easy way to prevent that is to just put a piece of fabric in between the teeth. I think it was originally on RD 500 cranks, which are geared together. So as you can see, that will just hold it. And I'm doing this to 14 foot-pounds. It's, I think, a 3/8 thread. Similar sized threads on the rest of the bike have a similar tightening torque, so I think that's good. And we should find that we can rotate that. However, my play has disappeared, so maybe this is tightened down onto the taper further than when I was experimenting with it. So what I'm going to do is I'm going to take one of those shims out and see what our play's like. Okay, and this seems like as good a time as any to show you the two-leg puller being used to remove the pinion from the taper. So we should just be able to tighten that, and off it comes. And I'm going to ditch one of these thinner shims, and we'll try that again. I didn't have any way of tightening the pinion down that firmly while it was off the bike, so that's been at least part of the problem. So we'll tighten that down again and see where it lands up. Okay, that's it refitted, turning freely, and we just have that little bit of playback. I think that's absolutely fine there. I'm not too worried about expansion. I'll put the idler gear back in. Now, some people would actually not do this until they were setting the timing, but I find it's impossible to tighten this properly without some rotation, so I just like this end fixed, and then when I'm setting the initial position of the points cam, I'll do it with the taper on the opposite side, because it's much easier to just hold everything still while you tighten that down. But yeah, that's all turning now, and you can see that's rotating with the engine. So that's all good. Also, while we're working on this side, some people find they run out of adjustment on the slots in the contact breaker plate when they're trying to get the timing right. And one dodge for that, if you don't want to dismount all of these tapers, is if you disengage that idler gear, you can rotate this one tooth either way, and that should bring you back into adjustment on the the slots on the other side. Just a useful little cheat there. Okay, the next job's going to be to get the other side of the assembly installed, so the advanced retard unit and the contact breaker back plate. I'm going to want to set the engine in roughly the right position to engage the taper on the other side. So what I'm going to do is I'm going to try and set the engine to 0.8, not 0.8 of a millimetre before top dead centre. Now, in order to do that, I'm going to use this tool, which you may not be able to see, but it has a millimetre scale on it. This screws into the spark plug head, so once I've found top dead centre, and the height that is, I need to set the engine so it's 0.8 of a millimetre before top dead centre. It'll probably be closer to 1. This is a ballpark. There is adjustment in the contact breaker back plate, but I need to get it in roughly right ballpark before we can proceed. There's a couple of ways of turning the engine. One of them is to put the engine in gear with the back wheel off the ground, usually in a high gear, and actually turn the rear wheel to make the engine turn. The other way is to use a socket on either end of the crank and actually manually turn the engine. It's worth mentioning that you have to approach that 0.8 millimetre point in the direction of rotation of the engine. The reason for that is these are quite imprecisely made, and we've got 1, 2, 3, 4, 5 sprockets before we get to the shaft, and there's a little bit of play in all of them, and it adds up. As you can see there's quite a bit of rotation before we get close to powering that in either direction. So if I've turned it backwards to get to that 0.8, the engine has to turn that far before it starts moving the points cam. And that can add up. It'll make you quite a few degrees out. So we want to always turn the engine in the direction of travel and stop at the point we want to be at, rather than turning backwards towards it, and that makes sure all this backlash is taken up, and that's how the engine will be running. Yeah, that's me got the engine set at top dead centre. But you need to remember there are 2 top dead centres, and we want the top dead centre on the compression stroke. Because I'm in this side, I can tell that my timing markings, these little spots on the valve cams, are lined up. So that means I'm on the compression stroke at top dead centre. I've felt the exact point of top dead centre using the measuring tool, but because we've got these 2 single dots lined up and the double dots here against the timing pinion, that means we're on at top dead centre on the compression stroke. Okay, this is just showing that top dead centre tool in position. So we have a millimetre scale on there. It's screwed into spark plug hole, so as the piston comes up and down, that will move up and down. I've got it set to, as near as makes very little difference, 0.8 millimetres before top dead centre on the compression stroke. That is roughly the point where the points need to be opening with the ignition fully retarded. So we're going to set it to there, and we can adjust from that point. Okay, so this is looking at the left hand side of the distributor housing. You can see the oil seal and the end of the shaft there. This is my breather hose, which is kind of in the way, but not so much that I need to take it off. I'm going to fit the advanced retard unit, which fits on a taper inside the distributor shaft. This one has been fettled a little bit. It's got stronger springs which stop the ignition going fully advanced until the revs are slightly higher. This is quite a high revving engine anyway. So the first thing we're going to do is loosely fit that in there. And I'm going to add the centre bolt, but I'm not going to screw it all the way home because I still want to be able to rotate this. I just want to hold it in position for just now. Okay, And then we have our contact breaker backplate assembly. That also goes in here. It's sometimes a bit of a tight fit, but it should. There we go. That's in. And what I'm going to do is, we've got a slotted hole here. I want to give myself the maximum room for adjustment, so I'm going to put it in the middle of that slotted hole, and I'm just going to fit one of the nuts for just now, just to hold it in place. Okay, that's got it nearly there. Now I've actually I've turned the ignition on here because I want the points to be just opening at this point. So I've got the engine at 0.8 before top dead centre, and that's where I want these points to just be opening. So I'm going to just do the final rotation of this cam before I lock the taper down at this point. I want the points just to open. Now happily we've got two ways of seeing when the points are opening. One is to visually look at them, but with the ignition on I can either see the ammeter pop back up, because as you approach top dead centre it dips, the points close and then they open again. So it draws power, ammeter dips, spark jumps, ammeter comes back up. You can actually hear the spark jump the gap when you rotate this, and that's the point I want. Now I find this very difficult to grip, so I'm just going to use some needle nose pliers carefully to rotate that till we get the spark. There we go. I hope you saw that. You certainly should have heard it. So at this point I now want to lock that taper down onto the distributor shaft, which I do by fully tightening. I'm doing it fairly cautiously initially, just so we don't actually turn the shaft till the taper's got a hold, and then I can tighten it down properly. That should be fine. I'll turn the ignition off before I short circuit something. So that should be locked in now, and I can tighten it down. And that's our you can see it rotated the engine there, but that's fine. We've got a very rough setting there. This puts us in the right position to now set the timing properly. That everything's locked down on its tapers. Should be close enough so that if I rotate this backing plate one way or the other, we'll be able to get the timing in the right place. That's probably something to leave for another video. It's getting late-ish now, and I'll need to make the dinner. So I'll do the timing, the actual timing, as another video. This was just to get in the right ballpark to let me set the timing.